Hey there, David Chadwick again here from Tactics Studios. Welcome back to the third tutorial in our introductory series on the Defold Game Engine. This is going to be a really fun one. We're going to plunge into techniques that are used for gaining a user input, a very common feature in games, the ability to use your cursor or touch on a tablet, select a particular game object, drag it to another position, and let it stop at that new position. Let's go ahead and take a look at what that might look like. A couple things to notice in the final app. It's in landscape mode. We have a space image as the background. We've got a total of 10 planets that have been spawned to different random locations across the screen. We've got a cursor that's controlled by either touch or a mouse that can be used for selecting, dragging, and dropping any of those planets to a new location. And you'll notice that I've also placed a label on the cursor that'll provide a screen location. That's very helpful for debugging. Hey, I know you're raring to go. Hey, let's jump into it. Okay, as you can see in this diagram, we're essentially halfway through this introductory series. We're in number 3, focused on drag drop in this series of 7. But I would ask that you pay really close attention to the techniques associated with selection, dragging and dropping of game objects. These procedures, the approach that we're going to use that same approach in each of the follow-on tutorials in this series, as well as the detailed games we're going to do in a follow-on playlist. So pretty important that we focus today. Okay, hey, back to that whiteboard. What are we going to learn today? We're going to learn a total of 5 things. The first is we're going to learn the concept of a game object prototype. That's a template. Many games you're going to have a certain type of character, whether it be a car or an aircraft or something like that. And you have many of them. They're all going to look the same, but there are going to be many of them running around on your screen. The prototype in Defold is the technique you're going to use for creating a template. It's going to have maybe the same image. It'll have a script file underneath it that controls some of its actions. And that will kind of serve as the basic replication point that you'll use for your game objects. Coupled with that is the idea of a default factory. The factory is the technique that we're going to use for actually spawning those individual, what we call instances, copies of that particular game object. The second thing we're going to learn today is we're going to learn the concept of a collision object. That's the sphere or the square or even an odd shape that goes around your character that would send out a message to the rest of the project every time your character collides with another character within your game. Pretty important. So the unique aspect of today's tutorial is it's going to be called a kinematic collision object. What that means is the game object and that collision object are not going to be affected by the forces of gravity. If you place your game object in the middle of the screen, gravity is not going to pull it down to the bottom. It only will move when you move it. Okay, the next thing we're going to focus on is some script properties. This is also very important. We in our scripts, we want to have property values, numbers or strings, things such as that, that are unique to that particular instance that that script is attached to, so that when we change it in one of our cars, it doesn't affect a different car because it's of the same, generated by the same factory. The fourth thing we're going to learn is the concept of rotation using the GeoAnimate feature that we used in the last tutorial, only this time we're going to rotate using something called a Euler angle that will allow us to control the nature of the rotation. And last, and probably the most important aspect of today's lesson, is the cursor that we're going to create, the cursor game object that'll have a script within it, and it'll illustrate the techniques that are used for actually, when you click or touch, picking a particular game object as compared to all the others, and then dragging it and making sure that you don't affect the location, position, status of the other game objects. So with that as a long introduction, let's go ahead and jump in. Okay, before we get into the detailed step-by-step, let's just take a moment and go through the general design and the build sequence associated with the project. The design is pretty straightforward. We'll have a single collection, main.collection. Within that, we'll have a total of 3 game objects. We'll have a game object for the background. We're going to have a game object for where we locate our factory. That's going to be the create planet game object. And then lastly, we'll have a game object for the cursor. And we'll get into the details of each of those components that you see here in the design as we get into the build by build. There'll be a total of 5 major steps in building the project, pretty closely following the design parameters. The first is we'll do the project setup. You should be very familiar with that. It's going to be similar to what we did in tutorial number 2. Secondly, we're going to build a game object associated with the background, basically simply adding the background sprite. We're going to build a game object prototype. That'll be that template associated with, we're going to use planets for our game character associated with that. And then we're going to go ahead and build the game object associated. I call it the controller. This is the overall control, if you will, for the application. And that'll be where we individually spawn each of the 10 planets at random locations across the screen. And lastly, we'll build a cursor game object, which is really the mechanism you're going to use for touching or using your mouse control. Oh, hey, really? Hey, you've got this. This is exactly what we did in the last tutorial. Hey, go ahead, launch Defold, and let's create an empty project. Give it a title. You can call it Tutorial 3 Drag and Drop or whatever you'd prefer, and save it to a folder of your choice. Our first step is going to be modifying that initial project setup as shown in the game.project file. The title we entered earlier is reflected here, and the main.collection as the bootstrap setting is also here. At this point, let's modify the display resolution to reflect a 1.33 aspect ratio. That would be consistent with an iPad, and if you're building for a different platform, obviously you'd change the display resolution accordingly. Let's go ahead and change the width to 1024 and the height to 768. Another initial setup task is to ensure our input bindings enable the application to recognize either a mouse or a touch action. Let's double-click the game.input binding file within the Project Explorer, that would be under the input folder, and let's display those options in the scene editor. Check that the input mouse-button-1 reflects an action of touch. In order to upload a set of images into the project, I'm going to create a folder titled Images and place that within the Master Project folder. Then let's drag the following images into that new folder: an image of a planet, a small crosshair image to be displayed at the current cursor location, and a background image for the full application. After we've placed these images into the image folder, we'll need to create an atlas file. Within the Project Explorer, you can create a new atlas file by right-clicking on the main folder, select New, go ahead and select Atlas and pick a name for the atlas file. Double-click the new atlas file just added to the Project Explorer. Then within the outline window, go ahead and right-click Atlas, select Add Images, and pick the new PNG files that we just added. Don't forget to set the Extrude Borders parameter to 3. That will ensure our application avoids any color bleeding issues. I really prefer that each application has a background. That adds a great deal to the aesthetics of the game. So for this example, let's keep it simple and let's just add a game object to the main.collection, which includes a sprite containing a background image file. Hey, the process for adding the background is the following. Within the outline panel, right-click Collection, select Add Game Object, and in the Properties window, rename the game object. I've renamed it Background. Within the Properties window, we want to center the background on the screen. So let's set the X position to 512 and the Y position to 384. Hey, right-click Background. From that, select Add Component, and then select Sprite. Within the Properties window, select the source of the images as assets.atlas and designate the default animation as space background. The background's now set. There is a component called the factory that's used by Defold as the means to generate, often called spawn, a set of similar game objects into a running game. Importantly, the factory feature requires a prototype game object as its blueprint. That's essentially the template for all the new game objects it will generate. In setting up a prototype for this tutorial, the first step is to create a Planet Game Object file within the project panel. That'll serve as the basis for this prototype. Within the project panel, right-click Main and select Game Object. Once the Game Object option is selected, you'll have the opportunity to name this prototype. I've used the name Planet GeoPrototype. Our next step is to add a sprite component to the Planet GeoPrototype. With the focus on Planet GeoPrototype, within the Outline panel, right-click Game Object, select Add Component, and select Sprite. Within the Properties window, set the source to our image to Asset Atlas, and set the default animation to Planet. To complete the Planet prototype, we're going to need to add two additional components. First, a collision object that's going to be used to detect when the cursor is over a spawned game object. And second, a script file, which I've included to enable animation of the Planet objects. In order to support determining if a user cursor or a touch input coincides with the specific Planet game object, we're going to need to add a collision object to our Planet GeoPrototype. But before we do that, let's take a quick diversion and talk a little bit about what collision objects really are within the Defold Game Engine. Your game will most likely need to keep track of when game objects collide, or when they're affected by gravity. Here's a very simple illustration of what happens when two game objects, each of which is going to have a collision object associated with it as a component, what happens when they collide. First, let's add a game object, which, as we learned in the last tutorial, is essentially a hierarchy of components, and it has a position. Next, we'll add a sprite component, which is where we'll identify the image to be associated with this game object. Now let's add a collision object component with the same shape as our sprite. That would be a box. This collision object is like an envelope that surrounds that game character. And in this example, we're going to designate this as a dynamic object. Therefore, it will be controlled by Defold's Box 2D physics engine. To illustrate the role collision objects play, let's add another game object to the example. Now here's a game object that will represent a platform with a sprite image. This second game object will also have a collision object as a component. And the collision object enables us to determine if any other game object has collided with it. Let's go ahead and start this. Once we start the game, the dynamic object, the wooden crate, is immediately simulated by the physics engine and starts falling down due to the effects of gravity. The platform, because it's a kinetic object, remains stationary because we haven't included any control to it using a Lua script. So what happens when they collide? When the two collision objects touch each other, the default engine sends a collision response message to all the other game objects which would have a collision component. And that message provides all the essential information that a Lua script would need to receive and use within its internal logic. Okay, hey, back to creating our Planet game prototype. With the Planet GeoPrototype file in focus within the outline window, right-click it in the outline, select Add Component, and select a collision object. Once the collision object's been added to the Planet GeoPrototype, within the Properties window, you need to change the type of this collision object to kinematics. The kinematic collision type enables the application logic, basically your Lua script, to control it. It will not be affected by other effects of physics, such as gravity. Let's now add a shape to the collision object. That needs to match the shape of our sprite. Within the Outline panel, right-click our collision object, select Add Shape, and select Sphere. Within the Property panel, let's change the size to 150 pixels. To add some animation to this app, I've included a script file to the Planet game object prototype. Let's go ahead and add it now. Let's do that by first going to the Project panel. We need to create a new script file here, but we want all of our scripts in this project to be in the same folder. So let's create a new folder within the Tutorial 3 master folder and name it Scripts. Now in the project window, under that new scripts folder, right-click it, select New, and name the script Planet Geo. Okay, now we're ready to edit that script. It's going to show in the editor window, but it's going to have that empty script template showing. Let's remove that and cut and paste the following there. Note that we start all of our Lua script files with a short description of the logic provided. You're going to find that pretty important as you start building multiple games and multiple scripts. We are using a script property to designate speed. Importantly, use of a script property will expose the custom property for just a specific game object instance. What do I really mean by that? That means changing the speed variable of one planet is not going to affect the speed in the other planets that were spawned using the same prototype. The init function is essentially an initialization step. This function will be executed immediately upon a planet being spawned. The init function calls the GeoAnimate function, which we've seen before. That'll rotate the planet around the z-axis using a script property speed to control the speed of the rotation. Okay, hey, let's not stress about the exact syntax in this script file, at least not quite yet. But let's take a deep dive into some specific functions now, similar to how we reviewed the GeoAnimate function in the last tutorial. Within this segment, we've introduced a new default function, the setting of a script variable, the geo.property function. The name parameter is the ID of the property, and the value parameter is the default value of the property. Now that we've created our script, we need to add it to our game object. So with the game object in focus, go ahead and right-click it in the outline window, select Add Component File, and select planetgeo.script. Okay, now that that prototype is complete, the next step is going to be to set up a default game object which has a factory component. That'll be the means for creating multiple planets within the game screen. At this point, we've created a prototype for a planet game object that included a collision object, a sprite, and a script. But we now need to create a means to spawn instances of this planet. Our first step will be to create a new game object which will host a factory component, which we'll be adding here shortly. This is going to be done as follows. First, double-click the main.collection folder in the Project Explorer, which will then serve as the starting point for the outline. Within the outline panel, right-click Collection and select the Add Game Object menu item, renaming it to Create Planet Game Objects within the Properties window. Once the hosting game object has been created, you can add a factory component right within the outline window. Go ahead and right-click Create Planet Game Objects, select Add Component, and select Factory. Within the property window for the factory, you'll need to identify the prototype for this factory by selecting the ellipsis and then picking Planet GeoPrototype. That's what we created earlier. Within the script folder of the Project Explorer, create a new script file named Spawn Planets. Replace the template code with the code shown here. This is the Lua code that will generate a set of planets within the game world. As seen below, within the init function, two primary tasks are performed. The width and the height of the game world are determined as a basis for determining legitimate positioning for both the X and the Y. I'm keeping them within a margin of 100 pixels from the edge. It also provides a set of 10 planet game objects spawned at random locations across the screen. I've also included some print statements as a means to check various game parameters or game actions. That's a good habit to use when developing a new game application. Go ahead and read through the script file. The comments starting with -- should be pretty self-explanatory in terms of what the code is accomplishing. Now you're ready to add the script file to create planet game objects. Go ahead and right-click, select Add Component File. Then select Spawn Planets.script. Okay, that step's now complete. Whew. Within our spawning script, we've identified several new functions. The sys.getConfig, as described in default documentation, returns a string value from the game.project configuration file, in this case, the display width and height. One of the primary purposes of this script is to create the factory. Factory.create function includes the following parameters. The URL is the ID of the factory component that would spawn the new game object. The position is optional. That's the world position of the new game object. This would be in a vector3 format component. Rotation is also optional. That would be the world rotation of the new game object. This would be in a quaternion. Properties. You can optionally pass properties down to a particular spawned game object. That'll be done in a Lua table with any script property values that you want to initiate the game object with. Scale. This is also an optional parameter. That's the scale of the spawned game object. The scale can be expressed as a number greater than 0, which specifies uniform scaling across all the axes. Well, now with the planet prototype completed and the factory for spawning multiple planet game objects in place, the last major step is going to be to create a game object to reflect the cursor, whether the cursor is due to a mouse or a finger touch. This is an important feature in that it determines if the user has selected a game object and whether the user is dragging that game object to a location or simply moving the cursor to find the next game object. Let's first create a cursor game object and a collision object component. To do that, double-click on the main collection within the Project Explorer to place it in focus within the outline window. And within the outline, right-click Collection to add a game object. Let's name it Cursor. Then right-click the Cursor game object within the outline to add a collision object. Within the Properties window for the new collision object, let's change the type to kinematic, similar to how we changed the type of the Planet GeoProperty collision object. Remember, kinematic means that it is not subject to the effects of gravity. It's only controlled by our script. Similar to what we did for the Planet GeoProperty, we'll add a shapefile to the cursor game object within the outline window. Let's right-click Collision, select Add Shape, and select Sphere as shown here. Let's change the diameter of that sphere to 10 pixels within the property window. I've decided to add two enhancements to the cursor game object. These illustrate features that will be useful in future design as well as debugging activities. We'll be adding a sprite to the cursor game object as a means for displaying the cursor image. And we'll also be adding a label component which will be used to display the current position of the cursor, both X and Y. Adding a label component is accomplished in the outline window, first by right-clicking Cursor, selecting Add Component, selecting Label. In the property window, let's name the component as Cursor Label. Once this is accomplished, you can left-click Cursor Label and modify its properties. In particular, you can change its relative positioning as compared to the actual cursor location under the Pivot attribute. For this example, I've elected to place the cursor to the west, that's the left of, the label. Let's add a new script file to the script folder within the Project Explorer. First, right-click Scripts, select New, select Script, and we'll name this script file Cursor. The following Lua code should be copied and pasted, and that'll replace the standard template code that the Defold Editor 2 places within a new script file when you create it. Let's quickly summarize the logic within this cursor script. The header comments provide a summary of the purpose of the overall script. The init function acquires input focus, aka it's listening for input messages. That init function also sets several script properties that serve as control variables. The update function is called for every frame, approximately 30 frames a second. It gets the location of the cursor, updates the label with that new position, and resets the self collision ID script property. OnMessage is called every time a message is sent to this object. The if statement filters all collision response messages. The onInput function responds to the touch action, using control variables to drag, move, a planet if the touch is pressed, or drop it if the touch has been released, while checking that the cursor doesn't already have a planet it's already moving. Once the cursor.script has been saved within the Project Explorer, you can add the script to the cursor game object within the outline window as follows. Right-click cursor.go, select component file, and pick the cursor.script. Let's take a quick look at the syntax associated with some of the key functions that the cursor takes advantage of. Within our cursor script, there's several new functions that you need to be familiar with. The first is the onMessage function. This takes 3 parameters in addition to self. The message ID contains the name of the message. That's the name in a hashed format. Message contains the message data. That's in the form of a Lua table. The sender contains the full URL of the sending game object. Collision response. This message is broadcasted to every component of an instance that has a collision object when the collision object collides with another collision object. For the script to take action when such a collision happens, it needs to check on this message in its onMessage callback function. The message only reports that a collision actually happened and will only be sent once per colliding pair and frame. The following parameters. Other ID is the hash of the ID of the instance the collision object collided with. The other position is in vector3 format, and that's the world position of the instance the collision object collided with. Group. That's the collision group of the other collision object, again in hash format. Go.getPosition. This function retrieves the global world position of the game object as identified in the parameter. The ID is either in a string or a hash or a URL ID of the instance that you want the position for. It returns a vector3 instance position. OnInput. Since the cursor game object has acquired input focus, user input is captured by the Defold Game Engine and dispatched as actions to this function. It has 2 key parameters, in addition to self. The action ID is the name of the message as set up in the input bindings. This name is in hashed format. Action. This is a Lua table that contains the message data. For example, action.pressed. This is set to true during the first frame within which the input was detected, otherwise it's false. Or action.repeated. This is true if the input was repeated, otherwise it's false. Or action.released. This is set to true in the frame in which the input was released, otherwise it's false. Socket.getTime. Pretty simple function. This returns the time in seconds. We've now completed the drag and drop application. Although it may not seem it, we've addressed some game features that will become the foundation for games you want to build. It's using the touch/cursor as a primary user input device. It's provided the ability to select, drag, and drop a game object around the screen. You're going to see that we incorporate the structure and the logic from this tutorial in many of the follow-on applications. I just want to thank you for joining this tutorial series. I hope you're finding it helpful. I really appreciate your feedback. If you have any comments or recommendations, just fill in the comment section below here on YouTube. I'll definitely take a look at that and hopefully make this a much better experience for you. As I've said before, there's a text version of the entire tutorial located on www.tacticstudios.com. I'd encourage you to go on there. In addition to the text version, you'll find download links that will provide you a zip file with all of the project files to include the images that you can use to jump into these projects yourself. Last but not least, please subscribe. And let's look forward to the next tutorial. Tutorial number 4 is associated with movement, various techniques for moving game objects around the screen. So looking forward to seeing you here next time. Take care now. Bye.